QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's have this first question for this function. What is the vertex of the graph of the given function? The vertex of the graph is at -1 and 4. Second question. What is the axis or the line of symmetry of the graph of the given function? The axis of symmetry is at x equals -1. And for the last question, how many x-intercepts are there in the graph, and what are they? For this given function, we have no x-intercept. Did you get 3/3? If not, please continue viewing this video. Let's consider this given function, and let's try to have its vertex, its line of symmetry towards its graph, and the idea that in our answer earlier, there was no x-intercept. We are going to discuss it step by step, but then let's start with the vertex. The vertex is known as our point of inflection because it is a point in our graph where the graph changes its direction. And we are going to connect the vertex to the axis of symmetry or the line of symmetry because there is a shortcut analysis to that. To solve for the vertex, let us try to use the correct coefficients of this function, just like the coefficients of quadratic equation a, b, and c. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is 2. And C is your constant of 5. The vertex, as mentioned, is a point on our Cartesian plane. Hence, it's a combination of an x and y coordinate. Your vertex as to its x coordinate can be computed as -b over 2a. We simply plug in the values for b and a coefficients, and we will get the x coordinate of our vertex. For our y coordinate, you have 4ac minus b squared all over 4a. Same, we are just going to plug in here the a, b, and c coefficients to determine what is our y coordinate. But this might be complicated for some, especially for those who have trouble in memorizing stuff. Don't memorize that. Just simply look at this. Once you will get your x coordinate, just like any other point on our Cartesian plane, substitute that value of x in our function. The result should be its pair y coordinate. So let's try to illustrate it here. For our first, which is our x coordinate, we have -b over 2a. So you have here, your b is 2, so -2 over 2 times 1. You will have here a result of -2 over +2. That would mean the x coordinate of our vertex is -1. This value of -1 will then be substituted in our function, because our f of x is also known as y in terms of the Cartesian plane. So we can actually solve for this and pair it with our x-axis for a singular point, specifically here the vertex. So we'll have f of -1. Please don't forget to use parentheses if you're dealing with negative numbers. So the square of -1 plus 2 times -1, and you have here plus 5. The square of negative 1 is positive 1. You have minus 2 here, and you have plus 5. So the result for our y coordinate, or f of x, in this case where x is negative 1, is positive 4. This would mean that our vertex, or our graph, will change its direction at negative 1 and 4. This is our vertex. Let us try to illustrate this in our graph. We don't need to actually draw the graph, because the graph is not necessarily required in this video. But just for illustration and its connection later to the axis or line of symmetry, and probably for our intercepts, let me write it here. Of course, this is our x-axis. This is our y, or also known as our f of x. They are just the same. So our point is at negative 1 and 4. 1, 2, 3, 4. So this is our vertex here. Okay? Look at our, of course, one thing that we can do when analyzing or predicting our graph is looking at the concavity. Where does it open? Does this open upward, open downward? So look at our A coefficient. You might want to review previous videos on this, because there are also videos concerning this. If our A coefficient is positive, in this case positive 1, we are 100% sure that our graph should open upward. Okay? So it should open upward. It will open downward if our A coefficient is negative. In this case, it should open upward because our A is positive 1. As you can see, our graph changed direction from here to here, and it changed direction at this point, and then it goes up again. The axis of symmetry, or the line of symmetry, is the lines here. It's an imaginary vertical line which divides our parabolic graph into mirror images. Look at that line there, or axis. This, if my graph is accurate, it divides the graph into two mirror images, meaning they reflect one another. So we are going to determine what is this axis. In our grade 8 math, we learned that a line, when drawn on our Cartesian plane to be vertical, its equation is x equal to something. And that something is the point in our x-axis where that line intersects, in short, in this value here. This corresponds to the vertex here. In short, we are talking about the x-coordinate of our vertex, this one here. And this is the shortcut of our axis or line of symmetry. Even without this graph, of course we needed this graph here to illustrate, but even without this graph, just by getting your vertex, take immediately the x-axis, and that's your axis or line of symmetry, just like this. Even without your complete vertex, once you're done with the x-coordinate of your vertex, that is automatically your axis or line of symmetry, because this is the same value of x that is intersected by this axis or line, and this is where the vertex also is plotted. That's our axis or line of symmetry. Okay, so if our vertex is, say for example, just for example, this is 5 and 4, automatically without even the graph, our axis or line of symmetry is 5. But in this case, it's negative 1, so it's negative 1 here. Now we're done with axis of symmetry with its connection to the vertex. Now with this graph here, again, it is not needed, but we are going to use that in trying to predict or analyze the x-intercepts. The intercepts are a point on our x-axis where our graph will intersect. The graph doesn't include the axis of symmetry, okay? Just this parabolic graph. As you can see, this graph extends further up. It will never touch this x-axis here. That is why on our answer earlier in the third question for this quad quiz, there are no x-intercepts. There are 0 x-intercepts, okay? Because then again, it will never intersect the graph, the x-axis here with this graph. Now, how do we know how the number of x-intercepts and the name or the type of, or what do you mean by the, because x-intercepts are also point on our graph, the coordinates of our x-intercepts without this graph here? Here's the hint. The x-intercepts are related to your roots, okay? Related to your roots. This would mean here, we still need to solve for the roots of this. Okay? So if we're going to plot, again, this is without the graph, okay? If we're going to equate the function to 0, we can solve for its roots, or if there are possible real roots, okay? So here, since we have a complete quadratic trinomial, we can use here either factoring, completing the square, or the quadratic formula. But I believe this can no longer be factorable. Let's use here the quadratic formula. You have negative b plus minus the square root of b squared minus 4ac over 2a. Okay, this is the quadratic formula. We plug in the same coefficients here. So b squared, negative b is negative 2 plus minus square root of 2 squared. 2 squared minus 4 times 1 times 5. That's 4ac over, 4 times 5. Parenthesis times 5 here. That's parenthesis, close parenthesis, over 2 times a, which is 1. Even without continuing this, look at this area here, the radicand. Okay? 2 squared is 4. This is minus 20. This is negative, right? 4 minus 20 is negative 16. And when I take the square root of that, there are no real roots. This means that for this specific quadratic equation, there are no real roots. If there are no real roots, we still have roots but it's imaginary. But since there are no real roots, this connects to the idea that there are no x-intercepts, because the x-intercepts are related to your roots. If our graph will intersect the x-axis, the number of intersection tells us number of intercepts. And automatically, that is also the number of roots. But in this case, since we don't have any real roots, the graph will not intersect the x-axis because the roots are points on the graph that intersected with our graph, with the x-axis. There are no x-intercepts here. This is the explanation. That's why the answer on our third question is there are no x-intercepts because there are no real roots. So basically, x-intercepts are related to the number of real roots. In this case, there are none. So these are the discussions, very important discussions for the 3 items for this QuadQuiz. Subscribe now.